Hello. Today we're beginning a new unit. This unit is all about how we can solve systems of equations. So a system of equations is when you have two equations and you find a solution that works in both. So it's two equations that have the same solution and you can use them to find a missing number. Our first method that we're going to learn is one that you're already familiar with, the graphing method. Graphing, just like it sounds, is when you're going to graph both of the lines on a single coordinate plane and see where they cross. Because if they intersect, that point where they cross works in both equations. It's a solution to both. Let me demonstrate with example 1. So for the equation in A, we're going to use the intercept method. We're going to cover up x. That means I'm making x be 0, and that will tell me my y-intercept. Divide by 4, and y would be at 6. Then I'm going to cover up y because I'm making y be 0. That gives me my x-intercept, and so x is at 4. So I put a dot on the x-axis at 4. Now I connect those 2 points, and it's important to make sure you have your ruler going directly through the center of those 2 points. If you're off center, then you may not find the correct intersection point. All right, that's the first one. This one is A. Now we're going to graph B using slope and y-intercept. Our y-intercept is 2. Slope 1/2 means to go up 1 and over 2. And just like that, we have found a point where this line is going to intersect the other line. This is line B. This point where they cross is located at 2, 3. So that means that it appears 2, 3 is a solution for both. Now graphing is a very imprecise method, so we want to double check our answer. So we're going to do the check. Let me slide down here so you can see where I do the check. So we're going to say 6x plus 4y equals 24 is going to be replaced with 6 times x, which is 2, and then 4 times y, which is 3, and that should equal 24. So 6 times 2 is 12, 4 times 3 is 12, 12 plus 12 does equal 24. It checks. Now we're going to use the second equation to make sure it works in that one also. It can't work in just one because then it wouldn't be a system anymore. It has to work in both. All right, so here's our equation. We're going to change the y to 3. We're going to change the x to 2. And so this says half of 2, which we know is 1. 1 plus 2 does equal 3. So our coordinates 2, 3 is a solution that works in both equations. All right, let's do that again with example 2. Line A has a y-intercept of -2, and the slope is -2. So we'll go down 2 over 1, and I like to repeat that to make sure that my ruler stays on its path. Down 2 over 1, down 2 over 1, and then connect. So there's your line for A, and now we're going to graph B. I'm going to use the intercept method. I'm going to cover up x and find that y is at -3. I'm going to cover up y, and I'm going to find that x is at -2. Now I connect those 2 points. Let's see if I can get them to line up right in the center. There we go. And this is line B. So you got to look closely. That's why I said this isn't as a precise method as some of the others, but it does appear that they cross right here at 2, -6. Now it could have been further up or further down, depending on how my ruler might have been a little out of alignment. So we have to check and make sure 2, -6 does actually work in both equations. So let's do the check. So we're going to have y equals -2x minus 2. So y is going to change to -6. X is going to change to 2. And so this is -4. -4 minus 2 does equal -6. It works in the first equation. Now let's try the second equation. 3x plus 2y should equal -6. So we're going to go 3 times x, that's 2, plus 2 times y, that's -6, and that should equal -6. Well, this is 6. This is -12. 6 plus -12 does equal -6. It works in this one too. So that is the solution to that system of equations. And that's how you do the graphing method. So now what I'd like to show you is a few of the vocabulary terms that you're going to need when you're describing these. So when you have a system that does have at least one solution, both of these have at least one solution, because sometimes they can have more than one. But if they do have at least one, you call it consistent. There is a consistent solution. But if there is no solution, if the lines never cross, say if they're parallel, then you would call that inconsistent. We'll get some no solutions on our next set of notes. And then these two words have to do with whether there's many solutions or only one. So if it's consistent, you have to then explain, is it dependent or is it independent? So if there's at least one solution, if there's only one, you put independent. That would be consistent and independent if there's only one solution. These two examples are consistent and independent. Now, if you have multiple solutions, say the lines overcross themselves in multiple places, then you would call that dependent. So it might be consistent and dependent. And those terms are ones that you may need to know when you're describing these lines. All right, if you have any questions, let me know.